Hello there, Mr. Sutton here with the Pre-Cal Honors Chapter 2, Quiz 1, Extra Practice Number 2 solutions on solving polynomials. To solve this polynomial equation, let's first look to see if we can take out any common factors. It doesn't look like we can. These don't all have variables, and the best common factor you can take out in terms of numbers is 1. So other things to look at, I notice here that we have the fourth power followed by the second and a constant. This is actually then going to be quadratic form if your middle exponent is half of your first exponent. So we can factor this just like a quadratic, only we're going to have to use x squared instead of x when we split it up. So in order to split this up, it's going to be a little tricky factoring it. I'm going to use the AC method for this one since I have an a value that's not 1. So multiplying 2 and negative 15, that's going to be negative 30. And then I need factors of negative 30 that add up to 7. 1 and 30 won't do it, neither will 2 and 15. 3 and 10 will work though if I have negative 3 and positive 10. So I can split this middle term up then into negative 3x squared plus 10x squared. And now that I have 4 terms, I can solve the rest of the way by grouping. So taking a look at the first two, I can take out a common factor of x squared. That leaves me with 2x squared minus 3. And then for the last two, I can take out a 5. That leaves me with 2x squared minus 3. Now I can take out 2x squared minus 3, and that leaves me with x squared plus 5 in the other parentheses. Setting each of these equal to 0 and solving, for this first branch here, I can add 3 and divide by 2, so that at least gives me x squared equals 3 halves. And then if I square root both sides, that's going to be plus or minus radical 3 over radical 2. And if I simplify the radical, which I should here, by multiplying by radical 2 over itself, that gives me radical 6 over 2. Now for this other branch, I can subtract 5. And then if I square root both sides here, well, since I'm square rooting a negative, that brings out an I outside the radical. So this is going to be plus or minus I radical 5. And we can't simplify radical 5 anymore, so we are done. For this problem, let me first see if there are any common factors I can take out. It doesn't look like there are, but I've got 4 terms, so at least I can try grouping on this. For the first 2 terms, I can factor out an x squared. That leaves me with x plus 1. And for the next 2, take out a 4, leaving me with an x plus 1. Now I can factor out x plus 1, and my other parentheses then will have the x squared and the plus 4 in it. Setting each of these equal to 0 and solving, it looks like a value of negative 1 will zero out that first factor. And for this other one, I can subtract 4 initially, so I have x squared equals negative 4. But then I have to square root both sides. That's going to give me an I for that negative, and the square root of 4 is 2, so that's plus or minus 2i. Don't forget the plus or minus here, even when dealing with imaginary answers. For this problem, first I look to take out a common factor. It doesn't look like I can take something out of all the terms, but what I can do, since I've got 4 terms, is try grouping. So for the first 2, it looks like I can take out a 2 and an x squared. That'll leave me with an x and a minus 5. For the next 2 terms, this is a little trickier. So the best I can do here is to take out a negative 1. That leaves me with an x and a minus 5 as well. Remember, you can always take out either a positive or a negative 1 if you need to in these situations. Although you normally wouldn't do that, it's often needed for grouping. So now I can take out this x minus 5, and then I have a 2x squared minus 1 in my other parentheses. Setting each of these equal to 0 and solving, we see that x has to equal 5 for that first factor. And then for the next one, I can add 1 and divide by 2, so I have x squared equals 1/2. And then I can square root both sides. So initially, I can write plus or minus square root of 1/2. But now if I wanted to simplify that, this is really the square root of 1 over the square root of 2, which is just 1 over the square root of 2. Multiplying by square root of 2 over itself, I just end up with radical 2 over 2. For this problem, we're trying to find the remainder and whether the divisor is a factor of the dividend, and we also want the quotient. For all of these, synthetic division will give us this information. So to start that process, we write down the coefficients of the dividend. We've got a 1 for the 1x cubed, followed by a 2, a -5, and a 7. And since there's no missing terms here, we don't need any placeholder zeros. So for my box number, I'm going to use -4 because that zeroes out the divisor. So now leave some space, draw another line, and we start our process in earnest here. Let's bring down that first coefficient of 1. Now I multiply -4 by whatever's in this bottom row and put the answers in the second row. So -4 times 1 gives us -4 up here. And now to get the other numbers, I'm going to add these top two rows. That'll give me the rest of these bottom row numbers. So 2 plus -4 is -2. -4 times -2 gives me 8. -5 plus 8 is 3. -4 times 3 is -12. And 7 plus -12 is -5. This last number is my remainder of -5. Since that is not a remainder of 0, that means that the divisor is not a factor of the dividend. And for the quotient, that's going to be these other numbers that are not the remainder, starting with an x that is one exponent lower than the dividend. So if we started with an x cubed here, that means our quotient starts with an x squared because you basically divided x cubed by an x. So this 1 really represents 1x squared, followed by -2x, and then we have a +3 for the constant. To find the remainder and all the rest of this information resulting from this division, I'm going to use synthetic division. So we'll start with the coefficients of the dividend. That's going to be a 4 for the 4x cubed, followed by a -2, 3. For this x here, we're going to use 1, invisible coefficient of 1. And we got to be careful here. This is an easy one to miss, but there should be a constant after the x. Since we're missing that constant term, we have an invisible +0 to represent it, so I need a 0 placeholder in my synthetic division. All right, so let me get my box number now. That's going to be whatever zeroes out the divisor, which is going to be 1 in this case, because 1 minus 1 is 0. Leave some space, draw a line, and we'll bring down our first coefficient of 4. So now I'm going to multiply this 1 in the box by all the bottom numbers in this bottom row, and I'll put the answers in the second row. So 1 times 4 is 4. Now I'm going to add these top two rows, and that's going to give me the rest of the numbers in the bottom row. So -2 plus 4 is 2. And then 1 times 2 is 2. 3 plus 2 is 5. 1 times 5 is 5. 1 plus 5 is 6. 1 times 6 is 6. 0 plus 6 is still 6. And then this last number is my remainder of 6. Since that's not 0, that means x minus 1 is not a factor of this other polynomial. For the quotient, that's going to be these first 4 numbers that are not the remainder in the bottom row, starting with an x that's 1 exponent lower than the dividend was. Since the dividend started with an x to the 4th and we divided by an x, that means our quotient, our result, is going to have an x cubed as the first term. So this 4 down here really represents 4x cubed. And then this 2 is 2x squared, followed by a +5x and a +6. On this problem, I am being asked to take this polynomial and write all the possible rational roots and then find the actual complex roots. So the first part of this problem, the rational roots, I'm going to get a bunch of fractions that are combinations of the factors of the constant in the numerator and factors of the lead coefficient of 3 in the denominator. So we're going to have plus or minus fractions, and in the numerator I'm going to have, again, factors of 4, so that's going to be 1, 2, and 4. And then in the denominator I've got factors of 3, which are just 1 and 3, so that's not so bad. But now I actually have to put these into individual numbers or fractions. So I've got all the numbers up top here divided by 1, which is just going to give me all the numbers up top, 1, 2, and 4. So those are 3, well actually 6, because it's plus and minus, 6 of our possible rational roots. Next, let me take all these numbers and divide them by 3. So I've got plus or minus 1/3, 2/3, and 4/3, and those are all unique answers. If I got duplicates after reducing, I wouldn't bother writing them again. Okay, So at this point, I'm going to start plugging these numbers in to this function here, the p function, in order to see if I can find any zeros. If I do, I'll use a little synthetic division and go a couple steps further. So let me first try p of 1. And to make my life easier, I'm going to put my function on the calculator just so I can do a bunch of these quickly if I need to. So here I am on the calculator. Let me go to y equals, and I'm going to put in my polynomial, and I'll do that off camera real quick. So here we are. I've entered p of x as y1. Now, to make my life a bit easier, I'm going to go to table set, and I'm going to make sure independent is set to ask. That's going to let me plug in whatever values I want in the table, and it'll just give me the value back of the y value. So here I am in the table now. I'm going to plug in all of these numbers here, potentially 12 of them, until I get 0 for something. So if I plug in 1, let's see what I get. Press enter, and that gives me negative 10 back. So this is what I would have gotten using synthetic division. Let me keep going. Let me try negative 1. I like to do negative, positive, negative, just to help me keep track of things. So negative 1 gives me 0. Nice. I guess I got lucky here. So we tried p of 1. Didn't work out. We got negative 10. P of negative 1 gave us 0. So this is telling us that we should plug in negative 1 using synthetic division on the polynomial, and good things will happen. What those good things are, let us proceed to say. So setting up synthetic division, we've got 3, and next we've got negative 1 to stand in for the negative x squared. Next, negative 8, and finally negative 4. Let me set up my line down here. My remainder is going to be in this little corner, and I've got a box with my box number, which is going to be negative 1, the number that I know is going to give me 0 when I use synthetic division on it, because I already tried this on my calculator. So let me bring down this 3 times negative 1 gives me negative 3, plus negative 1 gives me negative 4, times negative 1 is positive 4, plus negative 8 gives us negative 4 again, times negative 1 still gives us positive 4, plus this negative 4 gives us, of course, 0. So this is telling me that I can factor p of x into x minus my box number, so that's actually going to be x plus 1. And these numbers down here, one exponent lower than the polynomial started with. So this 3 here really stands for 3x squared. This minus 4 is negative 4x, and this negative 4 is playing itself in this motion picture. So we've got these two parentheses being set equal to 0. To figure out what this 3x squared minus 4x minus 4 stuff is going to give me for an x value, I could try factoring it. It looks like it might be doable, but I think it would probably be just as fast to use the quadratic formula by the time I've tried all the different combinations. So let me go ahead and do that. We're going to have x equals negative b, so that's going to be negative negative 4, plus or minus the square root of b squared, so plus or minus square root of negative 4 squared, minus 4ac, so that's minus 4 times the a value 3 times the c value negative 4. All of that over 2 times my a value of 3. Simplifying this a bit, we've got positive 4 there, and then this is going to be 16, and this next bit of stuff here, let's see here, that's positive 48. 16 plus 48 is 64, so we have the square root of 64, and then down below we've got 6. And we can go a little bit further because we know square root of 64 is just 8. Okay, and I'm going to combine all this in a second and write some final simplified numbers, but let me go back just before I forget, and I'm going to write x equals negative 1 because of this parentheses here. I don't want to forget that after I've found these other x values. Next, we're using this stuff here now. We've got 4 plus 8, which is 12, over 6, which reduces to 2. And then we have 4 minus 8, so that's negative 4 over 6, reducing to negative 2/3. So because I got these rational numbers, that's telling me, yeah, I actually could have factored this and it would have worked. But again, I think quadratic formula was faster, so we're calling it a day on this one.